file directory value to the localhost /pipe/x, that then the service will append the file name. And then finally we set the enable file tracing value to 1. So file tracing will be enabled, and instantly the service will read these values and will try to connect the pipe, and the exploit will trigger the remote shell. So this is a demonstration. I run netcat locally. Then I have uploaded a .NET web page. This is Internet Information Services 7.5 on Windows 2008 Release 2. You can see there the version. And now we can see the special account. You can see there the account that the worker process of IIS is running under. Starting on Windows 2000 Release 2, Microsoft added a change in order to improve security, because in the past, by default, all the web application used to run on the network service account. And because that account is more susceptible to attacks like this, they changed it to this special account that actually it has the same privileges as the network service account, but it's a different account that will prevent other kinds of attacks. So we are here, we have a command shell with a .NET web page. I have uploaded the exploit, and the web page is running under a low privileges account. It only has impersonation rights. So I type the path of the exploit and the remote IP and the port and run it. And you can see instantly after running the exploit, I get the remote remote shell running under the system account. Like I said, it's very easy exploit, just using the name pipe trick. That is an old trick that had been used in the past. So after finding this issue, I continue looking at the telephony service to find maybe other issues, because it was too easy to find this issue. I saw that, oh, okay, there will be more issues. I found that the dialer.x application is used to dial, to connect, to make telephone calls, etc. with the modem. Because the telephony service is used for that, for remote access, for telephone connection, VoIP also. So I ran this application called Dialer. Windows, the process monitor, captured a lot of activity. So looking at the activity that was captured, I found an interesting key that I didn't see before. That is a telephony subkey on HKLM, Microsoft software, Microsoft Windows telephony. And looking at the ACL, I found another issue, another surprise. You can see there in the ACL of the registry key, the network service account has full control. So you may be wondering why this is an issue. Well, this is an issue because it breaks the new protections that Microsoft added. It breaks the process isolation, because this allows any service or any process running under the network service account to modify this registry key. This telephony service will read this registry key and act accordingly, depending on the code. And remember that the telephony service has this process handled from a privileged process that allow me to elevate always to system account. So this is another issue. But in order to exploit it, I would have to find what value could I modify in this subkey to be able to elevate privileges. So I started to look around at the different subkeys and values until I found one interesting value. There was many values called provider file name 0, 1 with different number at the end that had the data value was what is seemed to be a file name. So looking at the capture on process monitor, I noticed that the telephony service was trying to access these file names in the system32 folder, and you can see here that the service actually loaded that files as DLLs. You can see in the operation capture it says load image. That means that the service loaded that file as a DLL. That means the code inside that file is executed by the service. So I realized that this was very easy to exploit. So any process running on the network service account could change the value from these file names and put any DLL there and get loaded by the telephony service. So in order to exploit it, I need to find a way to the telephony service to load these DLLs, because now the telephony service loaded them because the dialer application was interacting with the telephony service. So I have to find a way to my exploit to interact with the telephony service. So first I just make sure that those files were DLL. So I opened the file with the notepad and check for the headers, and you can see the MF at the beginning, and then the string saying this program cannot run in those modes. So you can see it has a different extension at the end, but it's a DLL. So I started to think how to interact directly with the service in order to get my DLLs loaded in the service. So I went to MSDN and looking for information about the telephony service. So I started to look around on different information, looking at the different APIs provided by this service, and I found one that was really interesting and almost self-describing. The name of the API is, you can see here, line add provider. So when I saw this, it rang a bell in my head. You can see here the first argument, the first parameter of the API is called LPSF provider file name. It's almost the same name as the registry value. You can see the description of the parameter is a pointer to a null terminated string containing the path of the service provider to be added. So I thought I had to try this API to see what happened. So I built a very small program to test this API and to monitor if it really interacted with the telephony service and what was the result of executing this API. So I built a really small application. You can see the code here. It's very simple, just calling the API and passing as an argument toto.tsp. So I ran process monitor and I started to run this simple application to see what's happened. And first I ran it as an administrator. After run it, you can see there the telephony service tried to find the file on all the registered paths in the system. So it searched for the file, it didn't find it. So it didn't load it as a DLL, but I could realize that this API will allow me to try to load a DLL inside the service. So the next thing to do was trying to run the program as network service account. So I went to Windows task, create a new task to run this this test program, and set it to run on the network service account. So I ran it. I ran this task, and while monitoring with process monitor, and I could confirm that after running, the telephony service also again searched for this file on all the registered system paths to try to load the file as a DLL. You can see there the service trying to find the file on all the paths. So I could find a way to really exploit, very easy to exploit the issue, just calling this API, passing any DLL I want, and it will be loaded inside the telephony service. And from there, the DLL code will be able to elevate privileges by getting handled from the other processes, from the other process that was running under system account. So it's really simple to exploit. So I have to try one more thing. I have to try with local service account. Just in case, because I tried also with a regular user account, but it didn't work. It would have been nice, it would work, but it didn't work. So I tried with a local system, a local service account. Monitoring again for activity, I ran it. And to my surprise, there was also the service trying to access the file to load it as a DLL. So the issue was a little bigger than I thought, because having the network service account loading a DLL, it was understandable because the registry has full control for network service account. So it could modify the registry or call the API. It was almost the same. But in case of local service account, didn't have access to the registry key. But using the API, the local service account will be able to run code under a network service account, which is important issue, because you can access another process running under a different account, and it's very easy to exploit, just calling an API. So I also had to check the same issues on Windows 2003 to see if the issues were present there, but for the tracing functionality, the registry permission were fine. But the thing is that in Windows 2003 and XP, the telephony service run under the local system account. So it was a lot more easier to exploit, because you can just be in network service or local service account, load any DLL and run the DLL under the system account. So it was instantly an elevation of privileges calling an API. Another thing I noticed is because in order to elevate from the telephony service to local system account, we had to have that process handler always present in the telephony service. In my test, sometimes the process handler wasn't present there, so I didn't know what it was about. So I noticed that when I ran the dialer application and also my test application, a process handler was already being created too in the telephony service. You can see there, you can see dialer here, dialer process handle inside the telephony service. So I noticed that any application that interacted with the telephony service, we get a process handle duplicated inside the telephony service. So the next step was trying to identify exactly what was the service that was interacting with the telephony service and the service that was running under the system account in the SBC host process. So I went to the SBC host process, and it was running a lot of services. So I had to identify exactly what was the service interacting with the telephony service. So I started to look around, and one option was to start and stop the service and see if the handle disappear or not from the telephony service. But looking at the names of the services inside this process, I found the Rasman Remote Access Connection Manager service. And when I saw remote access connection, I said, oh, maybe this is because it could interact with telephony. So I